Hello everyone, thanks for joining us today. My name is Max from the Innisfil Idea Lab and Library. In today's coding tutorial, we are going to use arcade.makecode.com to make a tile-based maze game. As a quick preview to see how it all would work in the end, here's a finished version of the game. We have a little skeleton crawls around and tries to get to the end of the maze. That's the game we're going to make, and if you want to head to arcade.makecode.com, we can get started. If you would like to jump ahead and take a look at the finished game, you can head to the web page github.com/mlupo/idealab_codejams to find the finished MakeCode arcade game files. The game files are saved as PNG images, so you can click on one here, right-click and save that image. Give it a good descriptive name. And then, in the Finder, find that image, go to the MakeCode Arcade website, and you can just click and drag that image that you downloaded into the web page, and it'll load all the game code. In MakeCode Arcade, all the game data is interestingly stored inside a PNG image. At the main arcade.makecode.com homepage, click on New Project, and we'll start by giving our project a name. And then click Create. In some ways, this project is both easier and harder than the last thing we did in MakeCode Arcade. Lucky for us, it all has a pretty similar starting point. In the OnStart block, the first thing we're going to do is make our character. And so we head to the sprite drawer and pull up the set my sprite to sprite block and hit that into OnStart. Just as before, my sprite is a variable that is assigned the kind player and by default is given a blank square as its image. Of course, we're going to click that and improve upon it. Once again, please draw your own super fun character, but for me, for the purpose of speed, I will pick a default little guy here. Probably what I chose in the demo was a little kind of floating skeleton there, so we'll press done. So we have a little floating guy. Of course, nothing happens. No control is yet active. So head to the controller drawer and click the Move My Sprite with buttons. My Sprite is the default name of the variable, which signifies our character. We can change that name if you want to. So we'll say player 1. And then so it changes there as well. And so move player 1 with buttons at the speed of 100 pixels per second. So our character moves around a little game simulator here to our left. We can give our character an environment to move around in by using what's called a tile map. And this is what might be the hard part for some. A tile map is a game design concept which is replicated here in MakeCode Arcade in a pretty simplified way, but of course it still relies on some tricks and some inner knowledge of what's going on. So let's set our scene using the scene drawer, and we will set a tile map to blank. And so again, we have our gray square here, the opportunity for us to draw a picture. And oh, what a picture it is. You could, of course, draw your own tiles, as always, here. And so if you want to draw like a rock, here's a pink rock, that could be part of your map. Once again, though, for speed, there's a little gallery option on the side with built-in tiles. So what's a tile? What's a tile map? First things first, let's say your screen here that is used in MakeCode Arcade. If this was occupying a physical piece of hardware, that screen would be 160 pixels wide and 120 pixels tall. That's the resolution of our game screen. The sprite that we're using, the visual space of the sprite occupies about 16 by 16 pixels. So too, the tile map is split up into a set of tiles that are 16 tiles wide and 16 tiles tall. The tricky part for some, or at least for me at times, is the idea that each tile in itself includes a 16 pixel by 16 pixel drawing. If we were going to draw our own tile, that's exactly what we'd be working with here. We'd be creating a drawing 16 pixels wide and 16 pixels tall, and then we would use that tile to create our scene on this surface here. So using the built-in tools, as we will, the existing kind of grass tile here is a 16 by 16 picture in this grid of 16 by 16 tiles. What you might want to do, what I like to do, is to use our path graphic here, our path tile, and what we can do in the tile editor is just kind of draw out a path. And so where will our character walk to? What are some potential dead ends here and there? So a fun path you think our character can go on. Of course, some branching paths and all of that. So this grass will indicate our path in the game where our character can walk. And then we have a little tree graphic here. We can draw out our obstacles. There's also a paint bucket option here, which you can paint any leftover continuous areas. And so these combined tools are what make the tile editor really interesting. We have one picture, one graphic, and then we use that to replicate our scene, or replicate the graphics to create our scene. And we can pretty quickly make a convincing area. So here, let's call it a haunted forest, not too bad. In the tile editor, in MakeCode Arcade, we have this wall feature, draw walls. And so here we're going to want to create our trees as walls. Whoops, that made everything a wall. So we're going to draw out the walls. Everything that's now light red in the game will signify a wall. MakeCode Arcade does a lot of nice work behind the scenes. Anything that's considered a wall here in the tile editor will automatically be impassable by our player. So anything that's a wall, our player will not be able to go through. You don't necessarily have to fill in everything in like these interior shapes, because if the player can't go through this wall here, it doesn't really matter if this is a wall or not. I'm just going to be paranoid and make it sure everything is a wall. Okay, and eventually we're going to give our player a starting point somewhere in the map. Personally, I like the center of the map to be the starting point because then they have more than one path that they can go to. So we're going to make this little patch to signify where the player is going to start later. It's the 7th by 8th tile, so 7 across and 8 down. That's where that little starting point tile is. We will remember that for later. Okay, so with not too much work, we have our character flying around a scene, going through this little tile maze here and there. First things first, we're going to change how the camera works because the camera does not follow our character just yet. So in the scene drawer in our toolbox, we're going to look for our camera follow sprite block near the bottom, camera follow my sprite. And of course, we changed our name to player 1. So from the drop-down menu, yes, we have to choose player 1. So now the game works as intended. Camera follows our friend here, which is perfect. Little, I don't know, skeleton ghost. Okay, so to make our character start where we want them to start, kind of in the middle of the maze, the most confusing part of the maze, back under the scene drawer in our toolbox, we're going to find the place my sprite on top of tile map column row. So we'll do that. Our player 1, column number 7, row number 8, if I recall. There we go. So that's our little starting point there. Pretty good maze. No way to escape, but also no way to win this game just yet. So we'll need to make some adjustments there. in our tile map, we can continue drawing and making edits as we go. And so if I wanted there to be a special tile, let's say a flower tile, I'm going to put that way over here, where the player maybe least expects there to be the win tile. So this little different tile here, the flowers. I'm going to click Done again. And now we just need to add some logic to make the game winnable if they find and actually touch onto that tile. So if you recall from one of our last sessions, we used an overlap block. This is very similar, but it's going to be found in the scene drawer. The scene, as you might have guessed, has a lot of blocks which relate to the imagery and graphics on our screen. And so we're going to look for on sprite of kind player overlaps something at location. So another type of overlap block, we are going to create something to only happen when our sprite of kind player overlaps our flowers. So here's a flower. So that block has to match exactly the flower tile that we used earlier. And then the sprite here is a placeholder, and the kind player, of course, matches our kind player. So what do we want to happen? Pretty simple. Under the scene drawer, the game drawer, we want there to be a game over. Not to lose, we want our player to win. We want our player to win when they overlap the flowers. And let's give them some confetti. That's great. So we'll test that out one more time. Have our little skeleton finds the flowers. Perfect. How nice. We did win. That is true. So, not so bad. Our player can win the game. But of course, there needs to be some sense of danger here. There needs to be a way to lose the game. If you wanted to make a countdown, I titled the game Amazing Race, of course, so there needs to be some kind of timed element. Under the info drawer, we're going to pull open the start countdown. So you can be as nice or as mean to your players as you want. How long do you think the player should have before it's game over? The default is 10 seconds, which I guess is possible if you know exactly where to go. You might be able to get there in 10 seconds. But if you don't know where to go, maybe 30 seconds is not a bad duration. So this will start the countdown immediately on start. But of course, we should probably give our player some hint as to what the goal of the game is. And so lucky for us, we can pull open some text tools in the game drawer here. So from the game drawer, we're going to show some long text right at the beginning. Before any other aspect of the game loads, we want to let the player know what's happening. So find the flowers before the time runs out! Exclamation point. And then we'll make that take over most of the screen. So now our game loads. Find the flowers before the timer runs out. Before the time runs out. Not bad. They press the A key, which on your keyboard, if you're playing with a keyboard, is the letter Z on the keyboard mysteriously. So now they have 30 seconds to try to find that, and the player knows the point of the game, which is good. And then they should be able to find that, hopefully in time. Not too bad. And so, in terms of giving the game a little more visual flair, a little more danger perhaps even, there's a few things we can do. On the visual flair aspect, you might notice that all our trees have some black graphics here, some black here for some reason. That's because the actual sprite of the tree has a little bit of a see-through area, and where you would see the background. You can kind of see that here, not quite. To make that a little more visually distinguished, we can give our game just a background that matches the general color of the other graphic elements in our tile map. So what I would do in this case is under the scene category, just set a background color and make that the first thing that happens in the game. So by setting a background color to a color that matches the overall color of our grass tiles, we have a nice green here, which is, better than a black void. And then now our trees have a nice little kind of green color underneath, which again matches the color of our grass. Not too bad. In order to add some danger, let's make something a little more complicated. So we're going to step things up just a bit of a notch here. We're going to bring in the onGameUpdate block from the game drawer and plop that over there. OnGameUpdate, we are going to do some tricky things. We haven't used any logic blocks yet in all our previous videos with MakeCode Arcade. So let's drag that out. If true, then else. This is creating a condition in our game where if something is true, the action inside this block will happen. Else, meaning that this was false, then we're going to do something else entirely. And so what my plan is, what the goal here is, in order to kind of punish our player for making the wrong choices, we're going to slow them down in a particular way. In our tile map, what I want to do is draw some graphics, or choose some graphics maybe from our dungeon, that'll make it so the player slows down if they move over it. And so in order to kind of, again, increase the danger elements of the game, make it a little harder for the player in some ways, we're kind of going to make these hazards where they'll slow down a bit as they move across. So I've chosen the same tile for all of these hazards for simplicity's sake. And as the player moves across them, we want to slow the player down. So how do we do that? Well, very similar to our overlap, we're going to do some checking to see if our player is over a tile. We're going to go back to our scene drawer and look for a diamond-shaped one. So collisions, tile to the left of my sprite is blank. In the world of MakeCode Arcade, this is trying to check for a certain condition. The condition that this diamond piece is checking is if the tile, we're going to say in the center of our player 1 is our dungeon tile, then we're going to do something. If not, we're going to do something else. So what do we want to do? And here again, we're going to quickly jump up in complexity just a little bit. We've been working with player 1, which was a variable that we renamed, but the variable was made automatically to signify our player character here. Under variables, we're going to make our very own variable, and we're going to call it speed. What I want to do is adjust the walking speed of our character, and so we're going to create a variable called speed for this purpose. At the beginning of the game, we're going to set speed to what the player would normally move at 100 pixels per second, and then we're going to make it so player 1 moves with that speed. And so under variables, we're going to drag out a bubble. This bubble essentially contains the value that we applied to it earlier. So we're calling the variable by name as signified by this colorful bubble. And then if the player moves over this, well, what are we going to do? We're going to head back to variables. We're going to set the speed to maybe just a little less than half speed, what will become 40 pixels per second. If they're not over that dangerous tile, they're going to move at full speed, 100 pixels per second. We then need to reset the controller. So move my sprite with buttons. Oh, you know, even better, we'll just duplicate our existing one here. Move player 1 with buttons, with speed. Speed is now this, so same idea here, move with speed. So on the onGameUpdate block, we'll make sure this runs constantly, that we're always checking if this condition is true. If underneath the center of our player, there is this tile, reducing our speed and adjusting our controller to match. Set our speed to this, adjust our controller to match. Okay, let's just see if that was worth anything. Ooh, slow. And then we're back up to full speed. Slow. Well, I still won anyway. So you can adjust your countdown to be a little sharper, 15 seconds or something like that. In any case, this is the basics for how to make a quick maze-based game using a tile map in MakeCode Arcade. I hope you give it a shot, trying to make your own game in this style. Of course, a tile map can be used for anything. A game like the top-down Legend of Zelda series, for example, relies very heavily on maps that look kind of like this with their own tile maps. And so whatever you make, whatever you happen to do, I really do hope you share it with the library and hopefully see your fun creations soon. Thank you so much.